Let's take a look at a couple of examples of how to determine algebraically the limit of functions that are specifically piece functions or piecewise functions, as you may have learned of them. So the first one we have here, we have a function h that you see defined there. And notice that the limit that we're trying to determine is the limit as you approach 2. And notice how 2 is what I like to call the split point between the two pieces of the function. That is typically how you're going to see these, because if there's going to be any quote-unquote problem with the way this function looks, it's probably going to be at that split point between the two pieces. So the big thing we need to remember, if the limit as x approaches 2 of this function is going to exist, we need to make sure that the limit of the function as we approach 2 from the left must equal the limit as we approach 2 from the right. Remember, that's our big rule that we need to make sure happens in order for this limit overall to exist. So let's start by determining the limit as you approach 2 from the left. So if you take a look at the piece function, if we're approaching 2 from the left, that means we're approaching 2 through values less than 2. So we're coming towards 2 from the left side, so we're coming through numbers. Think of a number line. So like 1.3, 1.4, 1.5, 1.6, all the way up to 2. So take a look at the piece function. Which piece applies for numbers such as those? It's going to be the first piece, right? So that's the one we want to substitute into. So we're going to do 3 minus 2. Now notice how we actually substitute in 2. A lot of people think because we're approaching 2 from the left, we substitute in something just a little bit smaller than 2. No, we actually substitute in 2. All right, so out of that, obviously, we get 1. So now we're going to do the same thing from the right. So if we're approaching 2 from the right, think again of a number line. So now we're coming down towards 2 through numbers such as like 2.5, 2.4, 2.3, 2.2, 2.1, finally hitting 2. So again, if you take a look at the piece function and ask yourself which piece applies for numbers such as those, it's going to be the second piece. So it's into the second piece that we're going to substitute in 2. And notice again, we actually do the number 2 itself, not something just a little bit bigger than 2. So that gives us 2. Well, remember our big rule up here. This is a case in which the limit from the right does not equal the limit from the left. So what we conclude is that this limit overall, as we approach 2, does not exist. D and E. So let's take a look at another one. So very similar, we're still approaching 2, this time of a function that is entitled g of x. So once again, remember our big overall rule. In order for this limit to exist as we approach 2, it must be true that the limit as we approach 2 from the left must equal the limit as we approach 2 from the right. So let's start again with the limit as we approach 2 from the left. Now if you take a look at that function, you'll notice once again the split point is 2, and that's where we're concerned about finding the limit. So again, if we're doing the limit as you approach 2 from the left, remember that means we're approaching 2 through values less than 2. So numbers such as 1.7, 1.8, 1.9. And once again, it's that first piece that applies for numbers such as those. So it's into that first piece that we're going to substitute 2. And notice again, we actually use the number 2, not something just a little bit smaller than it. So that gives us 11 in the end. So now let's do the limit as we approach 2 from the right. So think once again of what that means. That means we are approaching 2 through values larger than 2. So numbers such as 2.4, 2.3, 2.2, 2.1, finally landing at 2. And in this case, it's the second piece that applies for numbers such as those. So it's into that second piece that we're going to substitute in 2. And notice once again, we are actually using the number 2 itself, not something just a little bit bigger because we're approaching from the right. So that gives us 4 plus 10 minus 3. That gives us 11. Obviously they match. Therefore our major theorem is fulfilled, that the limit from the right had to equal the limit from the left. So we can conclude that the limit of this function as we approach 2 overall is going to equal 11.